Okay, in this first video, and actually in all three videos, we want to talk about proving two sets are equal. And we will do three different example proofs of this. But in this first video, I want to start by just talking about what the proof strategy is in general. So if A and B are sets, and we want to prove that A equals B, then we will often show that A is a subset of B and B is a subset of A. And the point is, if you show both of those, then the only thing that can be true is that A has to be equal to B, right? It's not possible for A to be a subset of B and B to be a subset of A without them being equal to each other. The point is that there's a strategy for showing A is a subset of B or B is a subset of A. Remember that to show that A is a subset of B, we take X in A and show that X is in B. Yeah, so you take any X in A and show that it has to also be in B, then A is a subset of B. And for the opposite, you do the same thing, right? Take some X that's in B and show that it has to be in A, then B is a subset of A. Okay, now I want to explore this via a few kind of set relations, right? So let's explore this proof strategy by proving the following theorem that is a fact about sets. Okay, so I didn't number this theorem because it's not one that shows up in the book. It actually shows up as an exercise, but it is a fact. So that if A and B are sets, then if you take A set minus B, that will be equal to A intersect B complement. Okay, so that's the fact that we want to prove. Let me put this theorem in a box. Now, before we prove this, let's just make sure that we understand what this set operation is talking about, right? So let's just draw a simple picture. So on the left-hand side, if we have A and we have B, then A set minus B is, let's use a different color, I suppose, is this part right here. It's the part that's in A, but not in B, right? So that's A set minus B. Now, drawing pictures is not a proof, but it can be helpful for understanding. And so now I want to try to understand this right-hand side. Now there, I'm going to draw a series of pictures, and now I want to imagine my sets as living inside of some universal set U, because I want to take complements. And I'm drawing it as a rectangle, but it could be the entire XY plane, or it could be anything. This is just a diagram to depict the idea, but you don't want to get too handcuffed to what's going on here. But anyway, so now I again take A and B, and of course we know what A is, right? So A is set. Okay, now I'm supposed to intersect that with B complement, right? So in the second picture, I just want to draw B complement. So again, I want to draw it though in such a way that A is also present. So here's A and B, then B complement is of course, everything outside of B. So that is all this stuff outside here, but also all the stuff inside of A, right? Okay. So now the point is, if I intersect these two things, right? When I intersect them, then the only thing that's left, so this part inside of here is not in there, so it's not in the intersection. Everything that's outside of A is not in this other set. So when I intersect them, I get the same thing as what I had over here, right? I just get the part of A that's not in B. So that's just a picture to try to get some idea of why these two things should be the same, right? A set minus B should be the same as A intersect B complement. But now we want to give a proof because these pictures are nice for intuition, but it's possible that we've lied to ourselves a little bit in drawing these pictures. And so in order to know for sure, no matter what the set A is, no matter what the set B is, this will be true for any two sets A and B, we have to give a logical proof. So that's what we're going to do now. So here, I'll start the proof. And so we'll just tell the reader we want to show that A set minus B is equal to A intersect B complement. Now the point is that on the left, A set minus B is a set. On the right, A intersect B complement is a set. And we're trying to show that two sets are equal. And at the beginning of this video, I mentioned that there's a strategy for doing that, right? So we will start by showing. So we're going to start by showing that A set minus B is a subset of A intersect B complement. That's our starting place. And so to this end, we're going to take some x, which is in A set minus B. And now this is a direct proof because the only thing I can do is apply definitions. So now I just have to apply the definition of set minus, right? So by the definition of set subtraction, we know, well, we know that x is in A and x is not in B. That's how you define set subtraction, right? Okay, but if x is not in B, then we know by definition of complement that x must be in the complement of B. Because if you're not in B, then you're in the complement of B, right? Okay, good. Now, that's pretty good because remember, we're trying to show that x is also must be in A intersect B complement. We know x is in A. We just saw that x is in B complement. And now by definition of set intersection, we see that x is in A intersect B complement, right? It's in A and it's in the complement of B. That means it's in A intersect B complement. And so hence we see that A set minus B is a subset of A intersect B complement. Yeah, because we took an arbitrary x in A set minus B, and we showed that x is also an A intersect B complement. That's what it means to be a subset. Okay? So now we will show that A intersect B complement is a subset of A set minus B. Okay, so to this end, let X be in A intersect B complement. Okay, but now by the definition of set intersection, we know, so X is in A and X is in B complement. Okay, by the definition of the complement of sets, we find that X is not in B, and we're getting close to being done here. So now, hence, by definition of set subtraction, X is in A set minus B. Yeah, because it's in A and it's not in B. That's what it means to be in A set minus B. So we see that A intersect B complement is a subset of A set minus B. And again, that's because we took an arbitrary X, which was an A intersect B complement, and showed that it had to be an A set minus B. And so now the point is that since we have shown that A set minus B is a subset of A intersect B complement, and A intersect B complement is a subset of A set minus B, we conclude that A set minus B is equal to A intersect B complement. And that is it. That's the end of the proof. In the next two videos, we'll see two more examples that get a little bit more challenging of showing that two sets are equal. But notice that when we go through this proof, all we ever do is apply definitions of set intersection, set complement, set subtraction, set unions we'll use later. And it's just a bunch of applying definitions carefully and understanding what the ands and ors mean. Okay, good.